I think the network just went off. So I said, when
Network is bad.
when you recognize an hazard, the next thing for you to do is to what? Is to evaluate the hazard. So how do you evaluate an hazard? You evaluate the hazard by looking at it and try to calculate the kind of risk you get exposed. So the kind of risk you get exposed to, that is what I said. What is happening this afternoon? Anna,
we're hearing you.
You are hearing me, but the connection keep on going.
Network is bad.
The network is...
Yes, sir.
You can go on. We can hear you.
Okay.
The network is not good with over your side there.
I don't know what is happening now. So I said, so
it's very cool. It's breaking.
Yeah, imagine if an exposed...
I can't even see you, sir.
I'm on.
It's breaking.
I'm on. Imagine if an exposed wire is 15 feet above the ground. The risk is low because it's 15 feet above the ground. However, if you want to walk on a roof that is close to that wire, you have moved closer to it. That means you need to evaluate and calculate that, okay, because I have moved higher close to the wire. Also, if you want to carry a pole, and most especially if the pole is a metal pole, that means the risk is even higher because there is probability of the pole to touch the wire and get electrocuted. So that is what evaluating it's all about. So we must always evaluate the hazard. The first thing, last week we talked about recognizing the hazard. Sure, you will recognize the hazard, but how will you evaluate whether you are prone to the hazard or you are not prone to the hazard? So the most important thing is, how do you evaluate the hazard? My system keep on hanging, sorry. I can't move my slide.
What's wrong with your network this afternoon?
I don't know. So, combination of hazard increase risk. Combination of hazard increase risk. Sometimes combination of hazard can lead to increase in the risk. Combination of hazard increase risk. So first one, improper grounding or a damaged tools greatly increase your risk. If you are doing an electrical work and the place is not properly grounded, the earthing done for the building is not good enough. That means your risk of getting electrical shock will become higher. Also, if you are using a tool that is damaged, that also helps to increase your risk of getting shock. Wet condition. Everybody knows that doing electrical work when the condition is wet makes you more prone to hazard. So you need to make your decision about the nature of the hazard in order for you to evaluate the risk you are getting into. Can we see the picture? Can we all see the picture? So if we can see the picture, can we try and evaluate the kind of hazard we are exposed to in the picture? Just try and look at your mind and evaluate the kind of hazard the person is exposed to in the picture. The picture may look blurred, but there are a lot of combination of hazard in that picture. So the electrical hazard exists, for example.
You can see the picture.
Yeah. For example, the GFCI, if a GFCI keeps tripping, you have a circuit breaker that keep on tripping all the time, or you have an equipment that keep on tripping. It just keep on cutting power, just keep on cutting power. And some people will just continue to reset the fuse or continue to reset the insulator. No. If you keep on resetting the GFCI or you continue to work, there's a potential problem. You must evaluate the clue and decide what action should be taken to control the hazard. So if an electrical socket keep on becoming spark or something keep on happening in a house, all the bulbs keep on burning, irrespective that there's no power, serious power current. So which means there's something. So tripping circuit breaker or blow fuse show that there are too much current flowing in a circuit. So if a fuse or a circuit breaker keep on blowing off all the time, it shows that the current that is passing through that place is what? Is too high. Or a default or a fault exists in it. So you must always check it. You need to determine why is a fuse cutting all the time, or why is a circuit breaker breaking all the time. Also, an electrical tool or appliance or a wire that feel worms. When you just touch a wire and the wire feel worms and it's becoming hot, some people just say, that wire just hot. That wire got bononi. No. An electrical wire should not just be hot anyhow. It shows that there is the current in the wire or there is a fault existing in the wire. It shows that there is a fault or the current, the wire is carrying a current that is too much for the load. Imagine you want to use an AC that they said is 15 amps. And the wire that you are using or the socket that you are using is 13 amps or is 10 amps. It will be cutting all the time and it will be causing problem. Also, an extension cord that feel worms may indicate there are too much current for the wire size of the cord, or a fault is already in it. Maybe the wire has broken inside. Also, when you go around and you start smelling odor, of electrical, that shows that overheat insulation is happening somewhere within the building. So that is a cognizance that we must take out. One, fried or damaged insulation around a wire or other conductor is an electrical hazard because the conductor could be exposed. So sometimes a conductor or a wire can get exposed, but we will not see it. We will not see it. Rat may have eaten it up, or something, rat may have eaten it up while we are rolling the wire on the floor. It has spilled. And when it spilled, it gives us and exposes us to many hazards. So the best thing is always evaluate the kind of wire we are using, whether the wire is hot, whether it has it has spilled or something has happened to it. Because if a wire gets spilled and water fell down and there's current in the wire, there's probability that we can get shocked. Let's look at this case study. An 18-year-old male worker with 15 months of experience at a fast food restaurant was plugging a toaster into a floor outlet when he received a shock. Since the restaurant was closed for the night, the floor had been mopped about 10 minutes before the incident. The restaurant manager and other employees heard the victim screamed and investigated. The victim was found with one hand on the plug and the other hand grasping the metal receptacle box. His face was pressed against the top of the outlet. Let's look at it. They said if a male worker who has worked in a restaurant for 15 months was plugging a toaster into a floor outlet, he received a shock. You can see, they said that place was mopped 10 minutes before. That place was mopped 10 minutes before. The place was mopped 10 minutes before. The cleaner just mopped it with water 10 minutes before. And he now decided to go and plug a toaster. And he's even plugging the toaster on a floor outlet, which is close to the ground. And unfortunately for him, he put his hand on a metal. The victim was found with one hand on the plug and the other hand grasping for a metal. The metal has served as a conductor to the electricity because the ground is what? It's already wet. All his body has conducted electricity. An employee tried to take the victim's pulse, but was also shocked. So another employee who wants to come and check his pulse, somebody that is already in contact with electricity, another person is coming. The next thing he wants to do, he wants to come and tell the pulse of the person. Instead of the person to go and de-energize or off the socket, he's coming to test the pulse. The manager could not locate the correct breaker. So while they were looking for the breaker, where is the breaker? Where is the breaker? They couldn't find it, the correct breaker. By the time the circuit was open and turned off, the victim has been exposed to the current for 3 to 8 minutes. They checked the pulse of the victim and found that the pulse is going. By the time they call emergency people and they continue to rescue, by the time they take the victim to the local hospital, the victim has what? Has already died. Yes, is dead. The victim is dead. The combination of what killed the guy is one. He was working in a place that is just mopped. The cleaner just mopped the place with water. And he wants to plug a toaster. He's plugging the toaster on the ground and he's holding a metal. Somebody is plugging a toaster on a socket on the ground. The ground was already mopped. So which means he plugged something using a wet mop, a wet environment, is connected to the electricity. And the ground is mopped, which means it has water, and it's also holding a metal which run a current into his body. When the other workers want to come and check, instead of them to go and off this current, they want to come and check his pulse. The person that wants to check his pulse also gets what? Shocked. By the time they look around, they could not find the correct fuse.
Circuit breaker.
Circuit breaker. They use up to 3 to 8 minutes. That means his body has received electrical current for 8 minutes. By the time they take him to the hospital, he was pronounced dead. So which means, if you are working in a company, it is important for us to know where the safety materials are. We have to know the safety materials. If they know where the correct circuit breaker is, it will take up to 3 to 8 minutes to save the person. So when an accident occurs, when an hazard occurs, we must evaluate that what is the best option to save the person. And that is what they did not do, and it takes a longer time for the person to. So when they called people in, when they called evaluator in, later 2 electricians evaluated the circuit and found no serious problem. An investigation told that the victim hand slid forward when he was plugging in the toaster. His index finger made contact with an energized sprung in the plug. The other hand was on a metal box, which acts as what? On the ground. The current entered his body through the index finger, flow across his chest, and exit through the other hand, which was in contact with the ground receptacle. So you can see, it was not an electrical fault that killed him, but because he was plugging an electrical toaster and he was not concentrating, his other hand, his index finger was in contact with something else. And instead of, even when he was in contact with something else, instead of him to use the other hand on something that will not conduct electricity, he put the other hand on a metal. So his hand that gets shocked, the current pass through his body, and the metal help him to what? To send the current to the ground. By the time he sent the current to the ground, what happened? The current returned back to his body. Shocking him. So we must always evaluate electrical hazard around us very well so that we won't. So to prevent death or injury, we must first recognize hazard and take the right action. We must recognize hazard and what? Take the right action.
Right.
If the circuit had been equipped with a ground fault circuit interrupter, the current would not have shock off before the injury occurred. So which means we must always put safety devices in place in terms of electrical hazard. Also, the recent mobbing increased the risk of electrocution. Never walk in a wet or damp area. When somebody just mob a place, we should not go and on electricity. We should not go and carry something and said we want to plug it when we know that they just mobbed the place. Or rain I just fell down now, and that is the time you go and call an electrician to come and help you to do repair. You don't know whether the wood in the house or the roof, some of them are what? Are wet. Knowing the location of the circuit breaker for your work area is very, very important. Knowing the circuit breaker for your workplace is very, very important, because if somebody gets shocked, if you know the circuit breaker, you can quickly go there and switch it off. When you switch it off, the person will fall off because there's no current again in it. So what is our takeaway message for today? What is our takeaway message? Working with electricity is inherently dangerous, and it is critical to ensure that safe working conditions are always in place. So if you are an organization, you must make regular communication, education, training, and safety meeting. These are very, very important. Regular communication, education, and training is very, very important. We should train, retrain, and train, and train, and retrain. Because human beings, we forget things easily. We always feel by the time we are working and we continue to work continuously, you said, I'm used to this thing, I'm used to this work. So you become complacent and you become relaxed. And that makes us to get exposed to what? To hazard. Ensure risk assessment are in place. Thorough risk assessment. You assess risk before you carry out the job. No job, every job has a risk. So the best option for you is to assess the risk before you even do the job. Ensure that a thorough verification of electrical equipment has been conducted and regard to quality, labeling, design, and location before you carry out the job. It's very, very important that you do verification for electrical equipment, because they are the one that can trigger it up. Imagine you trying to hold a tester and you don't know that the tester you are holding is already broken. The tester you have with you is already broken, and you just take the tester and you go and use it to test current. What will happen? The current will fall into your body and it will cause an hazard.
Shock.
So reinforce the positive behavior of reporting all incidents, near misses, and unsafe condition. When an accident or incident occur in the factory or occur in our workplace, let us ensure to report it. Let us ensure to report whether somebody died, somebody did not die, it's a near miss, it's caused something, we must report it. So because when we report it, that is what will help us to learn or guide against future occurrence. Ensure routine check of switchboard and distribution system. Because the switchboard and distribution system are normally the places where currents are distributed around areas. And they get melt. They have issues nearly all the time. So we must check it continuously. Ensure robust isolation process and procedure are in place. Make sure that you isolate and you put proper procedure for isolation. You insulate where you are supposed to insulate. You put circuit breaker where you are supposed to put circuit breaker. Sometimes we tend to compromise about money. We don't want to spend more money in saving life, but we find out that saving life is more important than saving money. So as an individual, As an individual, what should we do? When you feel that a job is not safe for you to do, when you feel that a job is not safe for you to do, please don't let us do the job. Don't do the job if you know it is not safe. Always ensure a risk assessment is in place and you are familiar with the risk control required for a task. If they ask you to go and do a job, ensure you carry out the risk assessment. Do the risk assessment. Know whether you are prone to hazard in it or you are not prone to hazard in it. It is very, very important for you to do what? To do a risk assessment. Always check and confirm tag out and log out in every place. Always ensure that you check and confirm tag out and log out before you do anything, because you don't know whether somebody else is already working and that person has tagged the place out and you now go and put it on. You expose the person to hazard and that person may die. The next one is use appropriate PPE. Always ensure you use appropriate PPE. Use insulating mat, use safety shoe and tools. These are things that saves life. Electricity are things that we cannot play with. We cannot play with electricity. They are very, very dangerous. So it is important for us to use our PPE. Establish clear line of communication with other personnel. Make sure you share pure communication with other personnel. Don't hide the information. Don't hide the information from your colleagues. A simple information can save people's life. A simple information can save people's life. So always share information. Yesterday, when I was working on this, there's a little spark, but I don't think it's much. So if anybody wants to work on that socket, please look at it very well. You have saved a life. So ensure and establish a clear line of communication with other people. Inspect and test tools before you use it. Always check equipment. Always test tools before you use them. Some equipment must have broken inside, their wire must have cut, or something must have happened, and make sure you do what? You check it before you use it. Report all incidents and near misses. I have said that before. You must ensure that you check you report all incidents. Whether it is minor, whether it is near misses, whether it is fever, you must make sure you report them so that we can document it and try to do accident investigation to know what really happened. So today, we said we are talking about evaluating hazard. How do you evaluate hazard? How do you evaluate a risk? You have seen an hazard. The first thing you do when you see an hazard is what? You recognize the hazard. So when you recognize the hazard, what next will you do? You will evaluate it. Whether this hazard that I have seen, that I have recognized this thing as an hazard. Will it affect me or will it not affect me? If a container is coming and you are driving close to the container and you can see the driver hand is not straight, what are you doing? You are evaluating. This driver that his hand is not straight, so something can happen to me. You quickly what? Go away and pass another route. 2 minutes later, you hear that that container fell down. Because you are able to evaluate it, that's why you are able to what? Save yourself. If the exposure wire, an exposed wire is 15 feet above the ground, because it's 15 feet above the ground, your exposure to it is very, very low because it's 15 feet. However, if you now want to walk on a roof close to an exposed wire that is 15 feet, because you are walking on a roof, you have elevated yourself up closer to the wire. That means the risk is what? It's high. The risk is no more low. Also, if you want to carry a metal, you want to carry a metal conduit, and you want to pass it through that place that has a 15-foot wire, because you are carrying something that is long, that probability is going to touch it. So you need to evaluate. You won't say, so always constantly evaluate your risk before you work. You do the work. There are a lot of combination of hazard that we get exposed to. The combination of hazard increase your risk. So when there are many hazards in a place, the risk you get exposed to become increased. Example, improper grounding or damaged tools also increase our risk to hazard. wet condition also increase risk. You will need to make decision about the nature of the hazard in order to evaluate the risk and how to remain safe. And I gave example of the instrument here. It's an instrument, but you can't see the picture very well. The wire is exposed. Some of the wire are exposed, and the socket is also tripping. So there are clues that electrical hazard normally give us. Electrical hazard normally give us clues. When the wire is becoming too warm, or a socket is tripping off too often, it shows that there is something happening with it, and we need to what? Take precaution of it. Tripping circuit breaker or a blown fuse show that too much current is flowing in the circuit. If a circuit breaker continues to break all the time, or the fuse continue to blow off, that means the current is becoming too much. So we need to determine the causes. An electrical appliance or a wire that is feeling warm all the time means also that something is happening. An extension cord that feels warm may indicate too much current for the wire size. You want to use an AC, and you are using a flexible wire for an AC, or you are using a wire that is like one wants to kill itself, or you want to go and the electrician say, "Oga, you have to buy 15 amps for this." Okay, I don't have 15 amps. Help me to manage 10 amps, and you want to use it for AC. You can see that the power does not get the ampage does not correspond to the power that of the AC. So you need to use something higher. Evaluating will let you know that this wire is too short, or it cannot carry the size of this thing. When there is a burning odor in a place, it indicates that there is overheating of the insulation. That is also another way of evaluating an hazard. One, fried or damaged insulation around any wire or other conductor is an electrical hazard because the conductor can get exposed. Damaged insulation could also cause a short or leading to arc fire or cause fire in the house. I gave a case study of a male worker, an 18-year-old male worker with 15 months of experience at a fast food restaurant, and he was plugging a toaster into a floor outlet when he received a shock. The restaurant was mopped 10 minutes before. The restaurant was mopped. The ground was mopped 10 minutes before. And he now wants to go and plug a toaster. And he's plugging the toaster to a floor outlet. The floor that was just mopped, that's where he wants to plug the toaster. And when he was plugging the toaster, he plugged the toaster and he put one of his hand on a metal. An electrical floor that was just mopped, and he's plugging it, and he's even putting his hand on a metal. So what happened to him? He got shocked. When he got shocked, one of the employees also that want to come and try to save him, that one just decided to go after him straight. That one also got shocked because there's still current in his body. By the time they were looking around, they were checking around for the circuit breaker. They could not locate where this correct circuit breaker is. Before they locate it, the victim has been exposed to current for 3 to 8 minutes. By the time they call emergency people in, they take him to the hospital. He has what? He has given up the ghost. So when they call 2 electricians to come and evaluate the circuit, they found that the circuit has no problem. There was no problem with the circuit. But the problem was that the hand of the victim that he was using to plug, his index finger made contact with energized sprung, and he was touching a metal. He was touching a metal, and he also gets his finger touched on something. And that's where current passes through his body and it gets to the ground. When it gets to the ground, because the current cannot continue to flow on the ground, the thing come back to his chest, and that's how he died. So for us to prevent such thing, if circuits have been equipped with a GCFI, a ground fault circuit interrupter, the current will not have entered his body. The recent mobbing increased the risk of electrocution Never work in a wet or damp area. Any place that is wet, electricity does not like water. Don't work there. Know the location of a circuit breaker for your work area. That will help you to save your colleagues or other people. Take away message. Regular communication, education, and training is important. Always carry that risk assessment before you do any work. Do verification and conduct practical check electrical equipment very well. Check the label and design before you do any work. Ensure routine check. Ensure robust installation. If you are not feeling fine about a job, don't do it. Stop it. Your life is very, very important. Always use personal protective equipment when you are doing electrical work. Establish clear line of communication. Always tell everybody when an incident or an accident happen. You don't know the number of lives you will save. Thank you, ladies and gentlemen. Any question?
No question from here.
Also, this place, I don't have questions, sir. All clear.
Okay. Okay. If there's no question, we'll see by 4 o'clock for the second class. Thank
Thank
you.
you, sir. You're welcome, sir.
Thank you, everybody.
Thank you,
Bye.
sir. You're welcome, sir.
Okay.